with the idea of consecutive integers, we've established what they are. Consecutive integers are n plus 1 and n, say. Okay, prove that the sum of the squares, see I'm reading properly now, of two consecutive integers is always an odd number. So the sum of the squares, so that would be n squared plus n plus 1 squared. And we don't know what it equals yet, but we'll see. So that would be n squared, and we'll just do a little boom, 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 n plus 1, n plus 1, and we're going to be timesing these, so we get n squared plus n plus 1. So that's plus, oh, I can see why it's going to be odd in a second. So that's n squared plus 2n plus 1. So that equals 2n squared plus 2n plus 1. And that would be, you could actually make this bit, you could take the 2 out, so we can even take 2n out. So 2n, n plus 1. And then at the end it's plus 1. So anything that's times by 2 is going to be even. This bit is going to be even. And then an even plus 1 always equals an odd. So that's why we end up with that. So this whole thing is times by 2. So therefore it is even. Even plus 1 equals odd. Therefore all sum of squares of two consecutive integers is always an odd number. And I'm just going to try one more that gets you 3 marks. Let's see which one's more fun. The squares of two consecutive integers is equal to the sum of these integers. Okay, prove that the difference, so we're going to be doing some taking away, of the squares of any two consecutive integers is equal to the sum of those integers. Okay, so it's two consecutive integers, they're not even, they're not odd. So we can take n and n plus 1. And now we've got to make them squares, so n plus 1 squared minus n squared. Difference between any of the squares of two consecutive is equal to the sum of these integers. Right, so the integers, so that's our, this is how we're finding this bit here, the difference between the squares of two consecutive integers. And the sum of those integers would be just be n plus 1, which equals 2n plus 1. So we win if this minus this equals this. Okay. Now, we already know what n plus 1 squared is because we just did it a minute ago. So it's n squared plus 2n plus 1. And now we're going to be taking away n squared, which is the second thing. And that equals, we cancel those out, and we get 2n plus 1, which is the sum of the integers, which is just there, which is marvellous. And that is how you do slightly more complicated, but not too complicated, proofs.